Okay. Thanks everybody for hanging around. I was a little more excited this morning when I found out I was second to last, but now I'm going last because the person after me had canceled. It's always a challenge keeping a talk like this to 5 minutes. We're a data technology company, but I will do my best. I've been here once before, and I think I can nail it this time. I was way over last time, so. We're going to talk about TokuMX. My name is Callaghan, and I'm the VP of Engineering at Tokutek. We're based out in Lexington. So who is Tokutek? In a sentence, we don't make databases. We aim to make databases better. And I'll talk to you about some databases that we work with that you'll probably recognize. So what does that mean? We do a little math here. If you take MySQL and you add some of Tokutek's special sauce, you get something we call TokuDB. It'll look to you like MySQL, but perform a whole lot better and do compression and some other interesting things. What I'm presenting tonight is a product we released back in June. So we took MongoDB, which is an extremely popular NoSQL database right now, and added to it the Tokutek special sauce, and we created something we called TokuMX. So what is Tokutek? If we look back at that formula, before I get there, we need to talk a little bit about something called indexing. So in databases, you put data in, but if you couldn't get it out quickly, it wouldn't be interesting. So databases need what's called indexes. Most indexes are implemented as B trees. Probably 99.99% of the databases that have indexes use something called a B tree. There are certain database implementations that don't need indexes at all. We won't talk about those. But the last bullet is really interesting and important. B trees were invented in 1972, and they haven't changed a whole lot. So it's a data structure. There's algorithms around them, but think 1972. And when I did, I thought to myself, well, many of you in the room today probably weren't even alive in 1972. But if we look to the left, that's myself, my brother Mark, and my sisters Kathleen and Christine. In 1972, I don't know what was up with my brother's pants. As I pointed out on Facebook today, which a lot of people had a good laugh at. And so if you look at us back in 1972 and you look at us in 2012, things change, times change. I was going to go through all kinds of technologies that have changed over the years, what computers look like, what we call the calculator, but I didn't want to waste a lot of time there with only 5 minutes. But what really has changed is this. Data's big, really big, and it's got to be fast. Small and fast is easy, big and slow is easy, but big and fast is important. And users today have been trained to expect instant results. We have instant messaging and texting and stuff, and it's just built into people now. Kids, customers, you name it. Web pages have to come up quickly, reports are due yesterday. And ultimately, hardware struggles to keep up. It can only do so much. So how can Tokutek help this problem? The founders of Tokutek come from MIT, Stony Brook, and Rutgers, and they created something called the fractal tree index. I could talk about a fractal tree for an hour. We only have 5 minutes. Look it up on Wikipedia, come to our website, take a peek. But its goal is to eliminate what we consider the shortcomings of the B tree. And so a little about TokuMX. So TokuMX, it's MongoDB plus compression, improved performance in transactions. If you're a database developer or data developer, you'll recognize some of these terms. I'll show it a little bit on the next few slides, but first up is compression. Making things small is important. Disks are not free. Fast disks are very expensive and farther from free, but ultimately what you see here is just a quick little graph to show comparing MongoDB to TokuMX. So the lines are pointing something out that's really interesting and important. This is a data set from a local, Andy Pavlo, some of you may have heard of. He went to Brown and he put up a bunch of public data sets, 60 seconds. So one of his data sets was some BitTorrent traffic data, and I took that and I loaded it into Mongo, and it took 20 gigabytes to store it in MongoDB. In TokuMX, with our mid-level compression, it took 1.75. So we're compressing the data down almost 12 to 1, which means you buy a disk that's this big, and it appears as if it's 12 times larger on commonly known data sets and patterns. Performance. This is kind of a scary-looking benchmark graph. I draw these all the time, but if you're not used to looking at them, keep one thing in mind: higher is better. TokuMX is blue. Way out to the right, we're inserting 100 million documents into Mongo and into TokuMX. At the exit, we're doing 10,000 inserts per second. MongoDB was doing about 125. So dramatically faster. It's just a different algorithm, different data structure. It shows the power of a fractal tree index. Last up is transactions. If you came from a database world, Oracle, MySQL, SQL Server, and you've caught the wave and gone NoSQL with something like Mongo, you've given up transactions. They don't support it, probably never will. We have it today. If you're interested in transactions, by all means, talk to me afterwards. But I think we're doing some really interesting stuff with MongoDB to make it even better than it is right now, because it is some pretty fantastic technology on its own. And I think I just made it. Are there any questions? Fractal tree indexes themselves, do we license them? Okay, so it's a good question. So the founders okay, he asked if we're licensing the technology. So a couple things I didn't have time to cover. A, we're open source. So the fractal tree index, the library, the base code itself is open source. There's a catch. The founders are from MIT, Stony Brook, and Rutgers. They discovered or invented this technology while being professors. So it's patents that are held by MIT, Rutgers, and Stony Brook, and licensed to Tokutek through the founders. You can use the fractal tree library. It's a GPL v2 license, but it does have a patent clause in the bottom that's granted right on through. So if you take it and you use it and you change it, you have to communicate those changes back. But the technology we're developing, again, is open source. So TokuMX is open source. It has to be because it's built on top of Mongo, which is open source. And our TokuDB stuff is all, as well, is part of MySQL, so all that code is available. We sell additional commercial features and support. Do we work with?
Do you use with the database users or database creators, and do you put any plugins to make any database better?
Yeah, so TokuMX, if you were a MongoDB developer and I stood up a TokuMX instance, you would be none the wiser. You could just use it as if you were using MongoDB. If you paid attention, you notice, oh, there's transactions, which Mongo doesn't offer. If you stored data and looked in the file system, you'd notice, wow, it's a lot smaller because we do compression. And there's certain use cases and patterns where we're just a lot faster because B trees are not as good as fractal trees at certain things like just raw insertion speed, as you saw in that graph. It's night and day if that's your use case.
Does this technology have any better or worse for structured or unstructured data?
Structured versus, well, that's the interesting, the role of the two products. So TokuDB is MySQL. Wire protocol, it's a storage engine. So if you're a relational type person, you like schema, TokuDB would be the right fit for you. If you like Mongo and the document storage model, then TokuMX would appear to you as MongoDB, just with some benefits that they don't offer. So you can start throwing your JSON documents into TokuMX, just like you would in MongoDB. Way back there?
Does this work with an ORM?
Does it work with ORMs? Absolutely, for an ORM that works with MongoDB would work with TokuMX. Our MySQL product, one difference that we have is we don't offer foreign keys, and most of our ORMs really like foreign key support. So Mongo ORMs, yes. MySQL ORMs, no.
The Doctrine does offer Mongo ORM.
What's that?
Doctrine? The Doctrine or TOC.
Okay, well, if it's an ORM that runs against MongoDB right now, it will run just fine against TokuMX. Same wire protocol, same language. It's Mongo with more code.
How long does it take for Tokutek the databases to use something as Tokutek? And also,
What was that question again?
how long does it take for Tokutek to convert like MySQL to TokuDB?
Okay.
And also, can you un-Tokutek databases to be all used with like other databases?
Sure. So MySQL has a plugin architecture for storage engines. So if you take our version of MySQL, still has NODB, still has MyISAM. So you can move into Toku, try it out. If you don't like it, you can move right out. All these databases today have tools to export your data to, say, flat files and go somewhere else. Your first question about implementing it on new technologies is interesting. The MySQL project began back in 2008, 2009, so we've been selling a MySQL product for 5 years. The Mongo project, for 1 month last year, we had a new engineer we hired built a prototype on top of Mongo just to try it out, to prove to ourselves it was worth pursuing. We did a prototype, had some really interesting benchmarks, and just this past February, we restarted the effort. So 3 engineers in 4 months rebuilt Mongo storage completely. Right now, if you look at TokuMX, all storage duties belong to fractal trees. There's nothing in the file system that looks anything like what we recognize for MongoDB.
Any plans to make a Postgres storage engine?
We've heard about it from time to time. The challenge with Postgres is MySQL and Mongo are multi-threaded, whereas Postgres is multi-process. I think that's a not small effort. The fractal tree library is meant to be multi-threaded, not multi-process. So it would be a big project. It's something we've thought about. It's interesting. We're open source now, and certainly if anyone wants to grab it out of GitHub and get to work, we'd be supportive. Time for one last question, if there is one.
Sure, I have a quick question. What is the impact on the performance because of all the compression you implement?
Compression, the only advantage compression gives us is if we go to do an I/O, instead of 16 kilobytes being 16 kilobytes, it decompresses in that example to say 256. So we get a lot more I/O efficiency. Most of the real benefits, for example, on insertion are we don't do any I/O at all. So putting a row in a fractal tree index oftentimes is just wire speed. As fast as you can push it at the database, we can absorb it. All right, thanks for your time.
All right, thank you for your question.
Join Boston New Technology Meetup. Sponsor an event or venue. Present your idea and attend to network with Boston's brightest. Details are at www.bostonnewtech.org and in the video description.